was that you have completed the proof. Let me see. So your AN was. So already you know that this sequence is monotonically increasing, right? AN. What about its boundedness? So this sequence will converge or not?
Converge, sir.
Converge. So how you show the boundedness? So since this is monotonically increasing, so you have to show bounded above, right? So how you show that this sequence is bounded above? How you show that this sequence is bounded above? How you show this sequence is bounded above? No one? In fact, this sequence is not bounded above, right? Okay, this sequence is not bounded above. How will show it? How will show it? Can anyone have tried it? Because it is yesterday's last problem, right?
يا طياري تكسي من جزائر.
So is it now okay?
Yes, okay, sir.
So this is exercise, okay? You have to complete that. You have to show like AM is not bounded. Okay. So you should get like AN greater equals to 1 by N by 2. Okay. So have you so what do you mean by subsequence? What is your guess? Suppose AN is a sequence. AN n greater than 1 be any sequence. And what do you mean by subsequence? What do you mean by subsequence?
Order.
Huh?
Order.
What do you mean by subsequence?
Sequence under a sequence.
So
Part of sequence.
so let nk k greater equals to 1 bn strictly increasing sequence. What do you mean by strictly increasing sequence of natural numbers? you mean by a strictly increasing sequence of natural numbers? That is n1 less than n2 less than n3. Okay, right. Is it clear? What do you mean by strictly increasing sequence? Means this inequality is strictly greater than. So n2 is greater than n1, n3 is greater than n2. Okay, and we will see soon with an example. So then what will be the subsequence? Then the sequence A and K. A greater equals to 1 is called a subsequence of An. So the definition is clear. Suppose An is 1 by n. Okay. Then can you give some subsequence of An? So what will choose your nk? What do you choose as nk? Anyone? So this sequence already have studied. Now subsequence, what is the definition of subsequence? A and K, where nk is strictly increasing sequence of natural numbers. Okay. So can you give some subsequence of an? No one. So what should I choose nk? What should I choose nk? What should I choose nk? Hmm? What should I choose nk? Suppose this is all even numbers, okay? Nk is 2k. Then what will be ank? What will be ank? What will be
1 by
this
2k.
sequence? Yeah, that means all. So
1
what should
by
I
2k.
get? A2, A4 is not it?
Yes, sir.
A6. So A8 like that. So you will get 1 by 2, 1 by 4, 1 by 6. Got it? What do you mean by
Send one
subsequence?
more time.
Okay. So n is here sequence is 1 by n. That is clear, right? In example. Now, so n element is 1 half, 1 by 3, 1 by 4, 1 by 5, 1 by 6, like that, right? This is your an. Now what we are saying, we have to construct some subsequence. That means some part of it. So it has suppose, so we can consider what would we mean by a up to n. What do you mean by a 2n plus 1? So this is a strictly increasing sequence of natural number. Is not it? This 2n.
Yes, sir.
Now if we construct a to n, we will get only the even terms. Okay, we will get only the even terms. So what is this one? If we take this one, suppose 2n plus 1 or 2n minus 1, we will get all these odd terms. Okay, we will get all these. Oh, this is even. So then if we construct, so this is a sequence of all. So here already you have seen, this is your nothing but a to n. Is not it? Is it clear now?
Yes, sir.
Yes, sir.
So if a sequence un, if a sequence converges to L, then what will happen for the subsequence, limit of subsequence? Suppose 1 by n, that sequence converges to 0, right? That you have already proved. So what about the subsequence limit? Where a to n plus 1 goes? Where a to n plus 1 goes? Hmm? Where it should goes? Where it should goes?
L only, sir.
Hmm. So if the sequence an converges to L, then every subsequence should converges to L. What about the converse? What about suppose some subsequence converges to L, then can the sequence converges to L also?
Yes, sir.
Huh?
But it's true.
Suppose some subsequence converges to L, then the sequence is also. Suppose we take minus 1 to the power n, okay? The sequence.
No, sir, it won't converge.
So this sequence converges to where? This sequence minus 1 to the power n converges to where?
Depending on the value of n, it will converge.
No, this
to
sequence
this.
is not convergent. This is divergent.
Yes, sir.
Now, if we take some subsequence, okay, so n is, so if you take a to n, so a to n will be what? A to n converges to
1.
1. So there is some subsequence converges to 1. That does not imply, right? That does not imply that n also converges to 1, right?
Yes,
Is
sir.
not it? A to n plus 1 converges to minus 1 for this sequence, but the sequence is divergent. Okay, so suppose if, so we can write that if two subsequences converges, okay, to two different limits, then what will happen? Then the original sequence is divergent, okay? So for 40, huh? So if you can show that for some subsequence, the sequence converges to somewhere else, from some other subsequence, the sequence converges to some other numbers. If you get like that two different numbers, two subsequence limit, then the original sequence, suppose in this example, a to n converges to 1, all the event terms, and a to n plus 1 converges to minus 1. Okay, so the sequence should sequence divergence. Is it clear? Till now, you have any doubt? Till now, you have any doubt?
No, sir.
No, sir.
So no doubt, right? Okay. So when you say that a sequence A ये सीक्वेंस n converges to infinity. इसका मीनिंग क्या है? A sequence n converges to infinity. What do you mean by that? n converges to infinity. What do you mean by that? एक सीक्वेंस बताओ जो converges to infinity है.
1 plus 2 plus 3 plus 4.
n
X to the power n.
एक बेसिक एग्जांपल ऑफ द डाइवर्जेंस सीक्वेंस, सबसे इजी डाइवर्जेंस सीक्वेंस जो है
n sir, n greater than equal to
so in just n sequence of natural numbers, right? Just n, 2n, 3n, all will goes to infinity, right? So if for every r belongs to r, what will happen? An is ultimately bigger than r. N, okay, if you take it for every r belongs to r, n is ultimately bigger than r. What do you mean by that? Symbolically, given r belongs to r, what will happen? Given r belongs to r, what will happen? There exists some n node, right? Such that what is the meaning of this sentence? N converges to infinity if for every r belongs to r, n is ultimately bigger than r, right? If you take any real number, you will get one natural number, that sequence, okay, which will be bigger than r.
Yes,
In
sir.
that case, n is said to converges to infinity. Then it diverges. We will come to that. So what will write in the terms of definition? That an such that an should greater than r for all r, for all n greater equals to n naught. Is it clear? Is this clear? An is said to converge to infinity. Okay, if for every r belongs to r, n ultimately bigger than r. Okay, so for any members of the sequence, if you take any real number, you will get one member of the sequence which is bigger than that real number. Similarly, an said to be converges to minus infinity when if similarly if for every r belongs to r, what will happen? Tell me.
an is ultimately smaller than r.
Right, ultimately smaller than r. So we'll say that n greater than equals to 1 is divergent properly if means either it converges to infinity or minus infinity. Okay, then in that case it said that n is divergent properly. Okay, suppose 2n sequence, it diverges to properly, that means it converges to infinity, right? I will prove it. I will prove this. Can anyone? How we can prove that this sequence n converges to infinity? How will prove this? What do you have to do? we have to use this. We have to get this one, right? I will get this one by which property? You should get one n naught such that this should. From which property you will get this? Anyone? So this we have to get some greater than r, right? I will get this by which property? Why it is taking so much time? By which property? You will say that for any
Archimedean.
yes, Archimedean. So what do you mean by Archimedean property? That for any real number, or we can find one integer, right? We can find one integer n naught such that this is greater than r by 2. Is not it? There exists one n naught belongs to n. So that means so you will get from here. So this is greater equals to 2n naught for all n greater equals to n naught, right? Once you get this one, you can use this one. So n naught is greater than r. That means it is greater than r. Is not it? Via this one. Is it clear? So limit tends to infinity, n is infinity. Is it clear? I will prove this that n equals to 2n, and for all n greater equals to n naught, and n naught exist by the Archimedean property, and n naught is greater than r by 2. So 2n greater equals to 2n naught, and n naught is greater than r by 2. That means 2n naught is strictly greater than r. So you have got that an is implies that n is greater than r. So n diverges properly. Is it okay? Is
Yes,
it okay? Similarly, you can show also that limit n tends to infinity, an plus infinity for a greater than 1, and a belongs to r. Okay, so can you show this? Can you show this? Can you show this or not? What will be the difficulty? Anyone? Anyone? I will show this. This is exercise. You can, I think you can show it, right? Whatever we have done earlier, and similarly, what you have to use? What do you have to use? Here,
Archimedean principle.
Property.
yeah, Archimedean property you have to use, and here it is given that a greater than 1, right? Then that means a can be written as a greater than 1 is given, right? That means a can be written as
A is greater than 1 by n.
no, a greater than 1 is given. That means a can be written as whatever you have done before. Similar procedure will hold.
Na is greater than 1.
No, if something is greater than 1, then what we have done? What we have done? We have written that a will be 1 plus some positive
1 plus
number,
x.
right?
L.
And then we have used What?
1 plus h cube of binomial
Binomial
equation.
theorem.
Binomial theorem. And then, so if you use binomial theorem and then you use inequality, so you'll get this is greater than nh. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
And then you have to use Archimedean property. Okay. So then you have to use Archimedean property. So you can see that this is greater than n naught h, greater equals to for all n, greater equals to n naught. So this n naught should exist, right? By Archimedean property. Is not it? And this by Archimedean property, this should be greater than r. Okay. Is it clear?
Yes, sir.
So any difficulty, any other difficulty? Any other difficulty regarding subsequence? Have you heard about Cauchy sequence?
No, sir.
Have you heard about Cauchy sequence? Hmm? Have you heard about Cauchy sequence?
No, sir.
So you have not studied?
Hard.
So 1 plus 1 upon lambda plus 1 upon lambda square ऐसा कुछ.
Natural number n onwards. Okay. If this definition holds, let me write. If for a epsilon positive,
That's something related with Cauchy's theorem.
huh? What?
Excuse me, sir.
Hmm? Anybody has any doubt?
Sir, I have a doubt regarding subsequence.
Bolo.
Sir, a bounded sequence, sir, the subsequence will be convergent or divergent?
Which one?
Sir, bounded sequence.
So this you can answer, right? This is bounded sequence or not? Minus 1 to the power n. Is
No.
it a bounded sequence or not?
No, sir.
No, it is not a bounded sequence.
No, yes, it is. It is.
So this is a bounded sequence, right?
Right.
Yeah, but this is not convergent.
Yes, sir,
So-
divergent.
So but its subsequence are bounded and also they convergent. So
Okay.
so we have studied till now that a convergent sequence is bounded, right? A convergent sequence is bounded, but the converse need not be true. An example is minus 1 to
Yes,
the
sir.
power n. Okay. Similarly, subsequence, that if a sequence n converges to L, then all the subsequence of n should also converges to L. But converse need not be true. An example is the same example, that minus 1 to the power n, its subsequence converges to two different limits, 1 and minus 1. So we can conclude that the sequence does not converge. Okay. And this sequence is also bounded, minus 1 to the power n. It is bounded by above by 1 and bounded below by minus 1. Okay. Is
Yes,
it
sir.
an minus am less than epsilon for all n m greater equals to k. The definition is this definition clear? So when you say that sequence is Cauchy, when you say the sequence is Cauchy,
Sir, what is K here?
k is any natural number. So
Sir,
for
what is
some
epsilon here?
epsilon is your definition that it can be very small positive real number. Okay, so this is arbitrary whatever you have studied in the definition of limit, the same epsilon. So for any epsilon you have to find 1k, right? In the convergence what you have done, that n minus l less than epsilon, we have done this, right? In case of convergence to l. Now here we are not talking about convergence, but we will come to that a sequence, a Cauchy sequence converges. Okay, a Cauchy sequence of real number converges. We will come to that. There is one property. But what is the definition? That for some k onwards, the difference between n and am should be less than epsilon. That means for after some inwards, that term, consecutive term, they are close to each other. Okay, after some consecutive term, they are close to each other. Is it clear? Suppose your n is m plus some other natural number. Okay, suppose n is some other natural number p. Okay, then what will get from this definition? That am plus p minus am less than epsilon. Okay, is it clear? Is it clear? So that means after some natural number onwards, you will get the term close to each other. Okay, then we will say that this sequence is Cauchy sequence. So here also you can see that what is happening with the tail of the sequence of the all the elements of the tail of the sequence, right? What is happening for first k, we don't care. Is it okay? So now we have two property. So one is that a convergent sequence is Cauchy. Okay, any convergence sequence is Cauchy. Okay, any convergence sequence is Cauchy. A Cauchy sequence. So these two property you have to remember. Is convergent. So suppose in exam some sequence is given and you have to show the convergence via Cauchy criteria. So if you say that, if you can prove that that sequence is a Cauchy sequence of real numbers, you can show that it is convergent. Okay. So till now any difficulty? So first subsequence, then Cauchy sequence, and then divergence sequence, right? So divergence sequence, from there you can show that using Archimedean properties. In the last class also you have seen some application of Archimedean property. So Archimedean property will be used all the time, right? Right. So any difficulty till now?
Sir, I have a small doubt. Sir, for x, sir, for a m plus p minus am mod is less than epsilon. Sir, will it be satisfying 1 by a m plus p minus 1 by a m?
Huh? What?
Sir, will this also satisfy for 1 over an minus 1 over am? mod less.
So you are asking for this sequence, or I could not understand your. This is for any definition, right? So suppose an is 1 by n.
Yes,
What
sir.
is it? What is your question?
1 over an minus 1 over am.
Yes. You can prove it. For suppose this is your example. This sequence is Cauchy.
Yes, sir.
So how will prove this? How will prove this? That an minus am, this should be less than epsilon. For any epsilon positive, you have to find a k, right? Such
Yes,
that
sir.
for all nm, you have to find a k, such that this is less than for all n m greater equals to k, right? So what is an minus am here? In this example, this is 1 by n minus 1 by m, right?
Right, sir.
So this should be lesser equals to,
Epsilon.
no, that you have to prove. But this
Yes.
should be lesser equals to, this should be
K.
lesser equals to. So see, you have to bring it in terms of k, because we have to find the existence of k. And from where we will get the existence of k? First, we have to write this in terms of k, right? And then
Yes.
there we have to use the existence of k. And from where you will get existence of k? Using,
Archimedean property.
yes, the same Archimedean property that I'm saying.
Okay, sir.
So this is your 1 by n plus 1 by m, is not it?
Yes, sir.
So this nm is n and m are positive number, right? So we have just written 1 by n. 2 by k is not it?
Yes, sir.
Because 1 by n lesser equals to 1 by k. 1 by m is also lesser equals to 1 by k. So 2 by k. So now you have got that an minus am lesser equals to 2 by k. Okay. And you have to show that this is less than epsilon. Is it possible?
Yes, sir.
From where? From where it is possible? Via Archimedean property, right?
Yes, sir. Right.
Via Archimedean property, what will get? 2 by k should be less than epsilon via Archimedean property. Is not it?
Yes, sir.
That means this property should hold by Archimedean property. You have already studied, right?
Yes,
For
sir. It will hold.
yeah, for all x positive, is not it? For all x positive, and suppose y belongs to R, you have studied like this, right? There exists one natural number such that nx greater than y. Is not it? So you have to
Yes,
use
sir.
this one. So this is less than epsilon. So n is a Cauchy sequence. Once it is Cauchy sequence, and you can see that n is a Cauchy sequence of real numbers. So 1 is a Cauchy sequence of real numbers. Okay.
Yes,
So
sir. I understood.
that means the sequence converges. So this property will be useful. Suppose you have get some difficult terms, you cannot check the convergence. So if you know that, you can easily show that this sequence is Cauchy sequence. You can immediately tell that the sequence is not a convergence. Okay. So for Cauchy sequence of real numbers, these both are if and only if, right? So they are any convergence sequence, but for the converse, it should be Cauchy sequence of real numbers. So we don't know about the Cauchy sequence of complex number. We are not studying here complex number for the time being. So everything is for the real number. So for real number, you can see that this is if and only condition. A convergence sequence is Cauchy, a Cauchy sequence is convergent for real number. Okay, both are if and only. So if one of them holds, the other will also hold. That you can use to show other properties of the sequence. So till now you have any difficulty?
No, sir.
So earlier you have taken one example, right? This n 1 half 1 by 3. Is not it? This sequence you have considered earlier.
Yes, sir.
So suppose this sequence is convergent or not?
Yes, sir. Conversion to 0.
Huh? This sequence is convergent.
Divergent, sir.
Divergent. Last class I told you, and I also just in the morning I wrote that this is not bounded. Right? You'll get. So this n is divergent. And I have given also exercise. So you can also show this via Cauchy criteria, right here. So what you have to show that n is what you have to show that n is what you have to show that this n is
Not Cauchy.
so n is not a Cauchy sequence. Okay. So how I will show this? I will show this. So this is your exercise. So have you solved all the previous exercises?
Excuse me, sir.
Huh?
So can we consider here also 1 over an minus am greater than epsilon, and then 1 over n plus 1 minus 1
The
over
greater than
n.
epsilon means you have to show that
Okay, sir.
so you have to show. Suppose this is not a Cauchy sequence. That means for some natural number onwards, you will get this one, right? This
Yes,
should
sir.
be greater than epsilon, right? For some mn greater or equals to k. So this is for some. Suppose you want to show that this is not Cauchy, right? So you have to find a particular epsilon. For that, if you can find that for any k, it will work. Suppose your suppose n is 2m. Okay, you have chosen some n equals to 2m,
Sir.
and then you can show that a of 2m minus, okay,
Yes, sir. Minus a of m is greater
am.
than.
Okay, so this for any k belongs to n, and mn in b for some particular value of mn, where mn greater equals to k. Okay, and this k should be for any when you want to show that this is not Cauchy. Whatever you take, you should get this one. Like in the epsilon, the limit extends to a f of x converges to L. Suppose it does not converges to L. What does that mean? Similarly, right? That if you take some particular epsilon for any delta, you should find that n fx minus L is greater than epsilon, right?
Right, sir.
So you know the positive, right? The opposite here. So for all epsilon, then there will be there exist, and where it is there exist, it will be for all. Any other doubt? So we'll come to the limit also, maybe after 3 classes or after studying. So have you studied series before? So let me give you one more problem. So this problem, have you solved it? Suppose a here. So I am giving you some other name, xn. An plus b to the power n to the power n. Okay. So now this is for all n belongs to n, and 0 less than a less than b. So you have to show limit n tends to infinity xn equals to b. Okay. Can we show this? Can you show this? You have any other class from 10? You have any class?
sir.
Yes,
Which
sir.
class you have now?
Yes, sir.
Physics.
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 Okay. So can you show this? You have to use sandwich theorem, or you can try with the any other method. Okay. So earlier you have studied series, right? Series you have studied earlier. Geometric series you have studied, right? You have studied earlier series, right? Suppose an
Yes,
is a
sir.
sequence. Suppose this kind of series is there. So where you have studied? Where you have studied? Where you have studied this one? Geometric series you have studied, right? Before 1 plus a square.
Yes, sir.
So what is the summation of this?
A over 1 minus R.
1 upon 1 minus a.
1 upon 1 minus a, right? And is there any condition?
Yes, sir.
What is that?
Sir, a less than 1.
So if it is suppose positive, so otherwise it is mod a less than 1 or just a less.
Mod a less than 1.
Mod a less than 1, right? So this you have studied already, right? So first you have calculated the sum also of this term. Suppose plus a to the power n, right? Then when n tends to infinity, what will happen there? Because when mod a less than 1, this we already know, limit n tends to infinity n. What is the limit? If mod a less than n, what will happen to that limit? What will be the value? Last class you have done it. Last class you have done it or not?
0, sir.
0, right? So that you have used in your geometric series. So from some finite number of terms, when you will get infinity, what will happen? You have done it, right? Or you have done it when model, maybe before that one, right? That if something is lies between 1 mod x in the 4th class, right? Lecture 4. So there I have used Microsoft Whiteboard. Okay, so you have any other difficulty? So we'll continue in the next class series. Okay. If you have any difficulty in sequence, you can ask in the next class. Okay. So we'll send one tutorial again regarding sequence and study also some books. Okay. Thomas Calculus books, Battle Server, and other references you have seen. I have already sent you, right?
Yes, sir.
So in the first class also I show you the syllabus, and then also I send you later on the syllabus. So you can check that. Okay. Okay, then see you. So please revise your materials for the sequence. Okay. Whatever you have book, or if you have some online notes, you can study your sequence, whatever we have followed, whatever we have covered. Okay, you just check in that book and study on your own. If you have any difficulty, you can ask in the next class.
Okay.
Okay. So those who have not attended the class today, so tell them, okay, how is 71. So let me see. I have recorded all the names who have attended today's class. So maybe tomorrow and see who has not joined. Okay. So if your attendance is less than 75%, you will be in trouble. Okay. Okay. Let me close it. See you Monday.
Thank you, sir.
Mm.